Hey guys, hope you guys are doing all right. Today what we're going to do is we're going to look at finding some antiderivatives, or it's also called indefinite integrals. Those can be used interchangeably. In the past couple weeks, we've used Riemann sums to look at approximating your area under your curve, between under your curve and your x-axis. So that's just been an approximation. This week, what we're going to do is we're going to see that now we can actually, if we're given a function, we can find the antiderivative, or for all you English buffs out there, if we have integrals, you'll hear the word integrate, which will give us what the function is. And then later on, we'll actually go and figure out, well, if they tell me where I start and where I end, what that actual exact area is. Today, our main focus or our goal is just to basically use the power rule backwards. Okay. So what that means is, if we go back to like when we first started derivatives and you were like, oh my goodness, I'm never going to get this. You've gotten so much better at this. It's going to be the same type of idea. Okay. So let's say I had the function, my original function was x to the third plus 2. So when I go and take my derivative, right, these are the things I'm doing. I'm taking that power of 3, I'm bringing it out in front, keeping my x, and I'm subtracting the power of 1. So 3 minus 1 to make that 2. And then my derivative of a constant is just c, or is 0, right, is nothing. And the c is where I'm going, so sorry about that. So then for f of x, if I had x to the third plus 3, again, if I use that same rule, it says bring my power out in front. So now I have 3x squared. I have to go and subtract 1. Derivative of a constant is 0, so I don't need to write the plus 0. Then if I had f of x equals x to the third minus 4, again, use that same rule. That's going to be 3x squared. All of these, even though some of them are shifted up 2, shifted up 3, shifted down 4, those are different graphs. Their derivative is the same. Okay, so that's something that's going to be important when we start going the opposite way, is until I know more information, and today we're not going to know more information, how to go and take it from this part to figure out, well, what did I start with? Okay, so if I went and looked at this first idea, okay, so this is how we were used to seeing it. This is my derivative, okay? If I want to get back to my original function, okay, what did I start with before I used that power rule? So if I want to go the opposite way, that's going to say find my exponent. If there's only one term, there's my exponent. Right now it has a power of 1. I'm going to go and add 1 to it, which is going to make that x squared. And what I'm going to have to do, I'm going to go the exact opposite way. So before, I started by bringing the power out in front and then subtract 1. Now I'm going and starting with, do the exact opposite. I'm going to add 1 to my power, which is why I wrote that there. Then once I have that new power, and again, that 2 is still going to be there because that was already there, I'm going to multiply by the reciprocal of my new power. Well, the reciprocal of 2 is 1 over 2. And then simplify. If I simplify that, that gives me x squared. And then I'm going to put a plus c at the end, because just like in this example, I could have a number added at the end, as long as there's no x on it. It could be whatever. I don't know what it is, so I just write plus c. So my original function is going to be x squared plus c. And again, check my work. Now go and use the derivative. Use the power rule the way that we know. Bring my power out in front. Oh, there's my 2. Subtract 1. Oh, there's my x. There's 2x. Derivative of a constant, 2, 7, whatever, is 0. So that gets me back to what I need. Okay. And again, you're going to see it written more like this idea. Okay. It's not going to say, well, here is my derivative. It's going to be tied in here. It's going to say, here is your derivative. This is the variable. You took it down a step. I took it with respect to x. Okay. So again, we already figured this one out. We just did it up there. So over here, where it says, what is my original function? I'm going to write x squared plus c. So on the next one, if I go back and use those rules, it says now start with the power. Add 1 to it. Then I'm going to multiply by the reciprocal and then write plus c. I could leave it as 1/4, or I can write as x to the fourth over 4 and then plus c. If I just had x to the fifth, that's going to go and tell me, again, use that rule of add 1. So that's going to make that x to the sixth, multiply by the reciprocal. Reciprocal of 6 is 1 over 6, and then plus c. And again, you don't have to go and write this down. If I go and bring that power out in front, 1/6 times 6 is 1, which is what I need. And if I subtract 1, it gets me to the fifth. Derivative of a c of just some random number is going to be 0. So that is my derivative if I took the derivative of what I have over here. On the next one, right? The 7 doesn't have, so I know it's going to have a 7 there, times, now go and use that rule. I have x to the 7th, right? When I go and add 1, if I multiply by my reciprocal, that's going to be 1/7. So 7 times 1/7 is just 1. So now I have x to the 7th, and then plus c. Okay. Now, I can also have the power rule if I have fractions. And on these, I'm going to have to go and rewrite those. I'm going to go back and say, well, 1 over x squared, well, that's really x to the negative second. So that's me rewriting that. If I go and use my rule says make sure I add 1. So that's going to make that really x to the negative first, and then multiply by the reciprocal. So negative 1 over 1 plus c. So that ends up being negative 1, and x to the negative first makes that over x, and then plus c. And again, if I went back here, and this is the same, right? Just that negative exponent says that x belongs in the bottom. If I brought that power out in front, then make that positive 1, and then negative 1 minus 1 would give me that negative x squared. So that is the same thing I have there. If I went and rewrote this, that's going to look like x to the negative 7th dx, which again says now add 1. That's going to give me x to the negative 6, which means I need to multiply by reciprocal negative 1 over 6. Simplify. Negative 1 over 6, and then x to the sixth. And what did I miss? My plus c. If I have radicals, well, this is really x to the 1/2. Then again, use my rule, which says add 1. So 1/2 plus 1, that equals x to the 3/2. Then multiply by the reciprocal, so 2 over 3, and then plus c. And to be honest, I would not try and rewrite that as a radical. I would leave it as 2/3 x to the 3/2. You could put it on top, over to the side. Just make sure that that's not in the bottom because it does not have a negative on it. If I looked at 12, this one says the cube root of x, which means it's really x to the 1/3. So again, use my rule, which says take 1/3 and add 1. So that's going to make that x to the 4/3. Multiply by the reciprocal. So 3/4. Nothing else to simplify. Just make sure I put the plus c at the end. So 3/4. And again, you could put the x on the top or out to the side. Just make sure your x to the 4/3 is not in the bottom. And again, I would not go and rewrite that as a radical. If I had this one, that's going to be 1 over, so that's x to the negative 1/4. And on this one again, if I add 1, that's going to make that x to the 3/4. My reciprocal would be 4/3. And I just need to write the plus c. So my original function would be 4/3 x to the 3/4, and then plus c. And again, if I check my work, if I multiplied 4/3 times 3/4, that's a 1, which is what I have over there. And then 3/4 minus 1 is the negative 1/4. So I have exactly what I need. Sometimes you might do some simple power rules, like what I have here. So this is really 2 over x to the 6th power. And again, I can treat it like what we did up here. Okay. And I can really go and move that 2 out in front of that radical. I can use some of those, not in front of the radical, excuse me, in front of the integral. I can use some of those properties from last week. That's the same thing. So if I have that, that's going to go and tell me that if I add 1, that's going to make that the negative fifth, and then multiply by the reciprocal. So I get negative 2 over 5. This time I have a negative exponent, so that 5 needs to go at the bottom, and then plus c. On this one, again, I have a number to the power, so make sure that I raise that to the power. 1 over 8, x to the 6th. So again, it's going to look the same as what I just had up there. Again, I'm going to use that rule from last week that says I can bring some constant out in front. And then we just did this part, right? So now I have 1/8 times negative 1/5 x to the negative fifth. So negative 1 over 40, because 8 times 5 would be 40, 1 times negative 1, and then x to the fifth plus c. And then the last one would be, well, I don't have a variable here, but it tells me what it needs to be. So if you just have a plain number, I'm going to get 2 to the x plus c. So they're just going right down my line. On the next one, again, I just have a number. So that means that in order to have 3 as my derivative, it would have had to have a variable to start with. Well, what variable do I have to start with? Whatever letter is second there. So 3t plus c, 3t plus c, and that's it. Okay, so the big idea is to now do the opposite of the power rule. Okay, it's going to go and tell me that I need to, let's say I have, so if this is my so if this is my integral, and I want to find out what my original function is, right? I'm going to go and use this rule backwards. I'm going to go and say add 1 to the top. I'm going to multiply by the reciprocal, so whatever that new exponent is, and then plus c. So if it says, hey, you have a rate, which is what my derivative is, and I see my integral, that's telling me to integrate. And when I integrate, I now get my original function, right? I get my original function, or a fancy way of saying that would be, that is my antiderivative. Okay, the opposite of my derivative. I hope that makes sense. Hope you guys are doing okay. If you need anything, you know you can always email me, write a comment. Have a great rest of your day.